Let us continue exercise 7.3. Let us do question number 13. Integral cos 2x minus cos 2 alpha divided by cos x minus cos alpha dx. Alpha is a constant here. Let us use cos 2x formula, which is 2 cos square x minus 1. Similarly, cos 2 alpha is 2 cos square alpha minus 1 divided by cos x minus cos alpha dx. 1 gets cancelled, 2 is common. The numerator becomes cos square x minus cos square alpha divided by cos x minus cos alpha. Let us factorize the numerator using a square minus b square identity. It becomes cos x plus cos alpha multiplied by cos x minus cos alpha divided by cos x minus cos alpha into dx. Cancel the common factor. Now 2 times integral of cos x dx. And cos alpha is a constant. Alpha is a constant, therefore cos alpha is also a constant, which can be taken outside the integral. It becomes 1 dx, the second term. Let us integrate and write. Integral of cos x is sine x plus integral of 1 is x into cos alpha and plus c. We have different methods to do this question, but the final answer will be the same. Question number 14. Integral of cos x minus sin x divided by 1 plus sin 2x dx. Let us replace this one by the identity sin square x plus cos square x. And plus sin 2x can be written as 2 sin x cos x formula. So that the denominator can be written as sin x plus cos x the whole square, because it is of the form a square plus b square plus 2ab, which can be written as a plus b the whole square. Now let us substitute the denominator as t. Differentiate both sides. Differential of sin x is cos x and differential of cos x is minus sin x times dx is dt. We have the same term in the numerator. The numerator becomes dt and the denominator becomes t square, which can be written as integral of t raised to minus 2 dt. Use x power n plus 1 by n plus 1 integration formula. It becomes t power minus 1 divided by minus 1 plus c and substitute for t. Question number 15. Integral of tan cube 2x into secant 2x dx. Let us split this power 3 as tan square 2x into tan 2x. And we have into secant 2x dx. And we know that differential of secant x gives us secant x tan x. Therefore, let us write this tan square as secant square 2x minus 1 using the identity into tan 2x into secant 2x dx. Now we know that differential of secant 2x gives us this term. Let us substitute secant 2x as t. Differentiate both sides. Differential of secant 2x is secant 2x into tan 2x into 2. Chain rule. First secant has to be differentiated and then 2x has to be differentiated. Into dx is equal to dt. Let's substitute. Therefore we get integral t square minus 1 dt divided by 2. Divided by 2, let me write it outside. Let us integrate t cube by 3 minus t plus c. Substitute for t. Secant cube 2x divided by 3 minus secant 2x plus c. Question number 16. Integral of tan power 4x dx. Let us write this tan power 4 as tan square x into tan square x. Let us write 1 tan square as secant square x minus 1, identity. Open the brackets. We get tan square x into secant square x dx minus integral of tan square x dx. We have integration formula for secant square. We don't have for tan square. So we will change this tan square as secant square minus 1, identity. And here this can be done by substitution. Let us substitute tan x as t. Differentiate both sides. Secant square x dx is dt. This substitution is only for the first integral, not for the second. Therefore, the first integral becomes integral t square dt minus the second integral. We have direct formula for secant square, so I am changing tan square in terms of secant square, which is secant square x minus 1. Again, I am repeating, the substitution which we have taken is only for the first integral. Integration is t cube by 3, and integral of secant square is tan x. Minus of minus will become plus, and integral of 1 is x, with respect to x we are doing, and plus c. Substitute for t, 1 by 3 times tan cube x minus tan x plus x and plus c. Question number 17. Integral of sine cube x plus cos cube x divided by sine square x into cos square x dx. We'll separate the terms. Sine cube x divided by sine square x into cos square x. The denominator is common to both the terms, and the second term becomes cos cube x divided by sine square x times cos square x dx. Let us simplify. We get sin x by cos square x. Sin x by cos x is tan x, and 1 by cos is secant x. Similarly, cos square gets cancelled. Cos x by sin x becomes cot x, and 1 by sin x is cosecant x. And we have direct integration formulae for both. Integral of secant x into tan x is secant x, and integral of cosecant x into cot x is minus cosecant x, and plus the constant of integration c. Question 18. Integral of cos 2x plus 2 sine square x divided by cos square x dx. In sine square x and cos square x term, we have the angle x, but the first term has cos 2x. So I'm going to use cos 2x formula. Cos 2x has 4 formulae. But since the numerator has sine square term, let us use the formula using sine. Cos 2x in terms of sine is 1 minus 2 sine square x. And the second term given is plus 2 sine square x divided by cos square x dx. These two terms are getting cancelled. 1 by cos square is secant square, and we have direct integration formula for this, which becomes tan x and plus c. Question 19. 1 divided by sin x times cos cube x dx. Since the denominator has cos cube x, I am dividing both numerator and denominator by cos power 4x. 1 divided by cos power 4x, and the denominator also should be divided by cos power 4x. The numerator becomes secant power 4, which can be written as secant square into secant square x divided by denominator becomes tan x. So keep this secant square x dx and change the rest of the function in terms of tan. Easily we can change secant square to tan square. The identity secant square x is 1 plus tan square x, and denominator is tan x, and we have secant square x dx. Now the function is in terms of tan, and we have secant square x dx, so we will use the substitution tan x as t. We have a perfect combination of tan and secant square. Differentiate both sides. Secant square x dx becomes dt. Let us substitute. We get integral 1 plus t square over t and dt. We can split this into two terms, 1 by t plus t dt. Now integrate and write. Integral of 1 by t is log of absolute value of t, and integral of t is t square divided by 2 plus c. Substitute for t, log of absolute value of tan x plus tan square x divided by 2 and plus c. Question 20. Cos 2x divided by cos x plus sin x the whole square. The angle given in the denominator is x, the angle in the numerator is 2x. So let us use cos 2x formula. Cos 2x has 4 formulae. We will use cos 2x formula using both cos and sine, which is cos square x minus sine square x, because the denominator has both cos x and sine x terms, and the denominator is cos x plus sine x the whole square. Factorize the numerator. A plus b into a minus b. We can cancel one common factor. We get integral cos x minus sin x divided by cos x plus sin x. Let us substitute the denominator as t. Differential of cos x is minus sin x and differential of sin x is cos x into dx is dt. Therefore, the numerator becomes dt, the same term we have in the numerator, divided by the denominator is t. The integration is log of absolute value of t. Substitute for t. Therefore, the answer is log of absolute value of cos x plus sin x and plus c. Or we may expand the denominator and write it as 1 plus sine 2x and substitute sine 2x as t. That is another method. Question 21. Integral sine inverse of cos x dx. Wherever we have inverse trigonometric function, if we are able to simplify the function, we will first simplify and then we will integrate. Since we have sine inverse, either we will change cos x to sine, that is sine of 90 minus theta formula, sine pi by 2 minus x, or sine inverse could be changed to cos inverse. Using the formula sine inverse of x plus cos inverse of x is equal to pi by 2. Therefore, this becomes pi by 2 minus cos inverse of cos x into dx. This could be simplified. It becomes x. Now we will integrate. Integral of a constant is pi by 2 times x minus integral of x is x squared divided by 2 and plus c. Now to do question number 22, we have to learn the next method. So write it in your formula notebook. If you have integrals of the form 1 divided by sine of x plus or minus a times sine of x plus or minus b dx, or integral 1 by cos of x plus or minus a cos of x plus or minus b dx, you have to multiply and divide by sine of a minus b or sine of b minus a. This is the method. If you have integral 1 divided by sine of x plus or minus a times cos of x plus or minus b dx, that is, one term is sine, one term is cos. We have to multiply and divide by cos of a minus b or cos of b minus a. This is the method. Write it down in the formula notebook and memorize. Here product of sine and cos or both sine, both cos are in the denominator, not in the numerator. If you have product of sine and cos in the numerator, we could have used that sine a plus b plus sine a minus b, those formulae. Now let us do question 22. Integral 1 divided by cos of x minus a times cos of x minus b dx. Both are cos functions here. Therefore, we have to multiply and divide by sine of a minus b or b minus a. You can do by anything. One divided by sine of b minus a into sine of b minus a integral divided by cos of x minus a times cos of x minus b dx. So I have multiplied and divided by sine b minus a. B minus a is a constant. So sine of b minus a is also a constant. That's why the multiplication term I wrote it in the numerator. The division term I wrote it outside the integral as it is a constant. 1 divided by sine of b minus a. Now the numerator sine of b minus a can be written as x minus a minus x minus b. Open the brackets and check. X gets cancelled. Minus a plus b you get, which is b minus a. So I can write b minus a as x minus a minus of x minus b divided by the denominator is cos of x minus a times cos of x minus b dx. This is an important method. Please memorize. Let us use sine a minus b formula for the numerator, which becomes sine x minus a cos x minus b minus cos of x minus a sine of x minus b divided by cos x minus a times cos x minus b dx. Just we have used sine a minus b formula in the numerator. Now let us divide. We have two terms in the numerator. Let us divide each term by the denominator. The first term, cos x minus b, will get cancelled. You get sine of x minus a divided by cos of x minus a. Cos x minus b gets cancelled. Minus the second term. In the second term, cos of x minus a is getting cancelled. And I am writing the leftover terms, which is sine of x minus b divided by cos of x minus b times dx. 1 divided by sine of b minus a, and this is tan of x minus a, and that is tan of x minus b dx. We know integral of tan. Sine of b minus a. Integral of tan is minus log of cos x or plus log of secant x. So let me write it in terms of cos. Minus log cos of x minus a divided by the coefficient of x is 1 here. And minus of minus will become plus log of absolute value of cos of x minus b and plus c. Now log a minus log b is log a by b. We know the logarithmic rule. So we can combine these two terms and write this as 1 by sine of b minus a, and this becomes log of absolute value of cos of x minus b divided by cos of x minus a. Or you could have given the answer in terms of secant. If you have multiplied and divided by sine of a minus b, the answer will be a little different. Question 23. Integral sine square x minus cos square x divided by sine square x into cos square x dx. This is an easy question. Let us separate the terms. Sine square x divided by sine square x times cos square x dx. This is the first term, and the second term is cos square x divided by sine square x times cos square x dx. Let us simplify. 1 by cos square is secant square x minus 1 by sine square is cosecant square, and we have direct integration formulae for both these functions. Integral of secant square is tan x, and integral of cosecant square is minus cot x. So minus of minus will become plus cot x and plus c.
The correct subdivision is A.
Question 24. Integral of e power x into 1 plus x divided by cos square e power x dx. Let us substitute e power x into x as t. We have to use product rule, u and v. U dash v plus u v dash. U dash is differential of e power x is e power x into v plus u v dash, differential of x is 1 into dx is dt. Here we can take e power x common and we get x plus 1. We have the same function in the numerator. Therefore, the numerator becomes dt and the denominator is cos square t. And 1 by cos square is secant square. And we have direct formula for integral of secant square, which is tan t. And substitute for t, which is tan of e power x into x plus c.
The correct subdivision is B.
Now you practice example 7, second subdivision. Now let us do example 6, first subdivision, which is integral of sine cube x times cos square x dx. We have to split the odd power. Odd power is 3 here. So let us take one power separately. So sine square into sine x dx, and we have cos square x term. Since we have sine x dx, let us write the rest of the term in terms of cos. So easily we can change sine square. Sine square is 1 minus cos square into cos square and into sine x dx. Since we have sine x dx, let us substitute cos x as t. Differentiate both sides. And sine x dx becomes minus dt. Integral 1 minus t square into cos square is t square. Sine x dx is minus dt. Let us multiply with minus t square. Therefore, it becomes minus t square plus t power 4. Let me write the positive term first. It becomes t power 4 minus t square into dt. Let us integrate t power 5 by 5 and t cube by 3 plus c, and let us substitute for t. cos power 5x by 5 minus cos power 3x by 3 and plus C is the answer.